Yo coders, today we will learn about object-oriented programming in JavaScript. Here in this video, we will be covering the fundamental principles that govern object-oriented programming, explore how they seamlessly intertwine with the dynamic and versatile nature of JavaScript. After watching this video, you can write more organized, scalable, and maintainable code. So stick with me and let's dive into classes and objects. Classes provide blueprint for creating object, acting as a template that hides both her data and methods. Here we have a class car. There may be many cars with different names and brands, and all of them will share some common properties like they will have a certain number of wheels, speed limit, mileage. They will also have certain common methods like starting the car, applying brakes. So here, car is the class, wheels, speed limit, and mileage are their properties. Start car and apply brakes are their member methods. Since the member methods are like functions, we can pass any number of parameters through them. Here, start car method accepts keys. Objects of a class are instances of the classes with the properties and behaviors defined within. It is created using the new keyword. Car is an instance of the class car. The new keyword is important, signaling that we are creating a new instance of the class. As we know, classes are user-defined data types, and Thar is an instance of the class car. Thar gets the type car. We can access the properties and methods of the object by writing the object name followed by a dot, and then we can see we get access to all the public parameters and methods. We can assign or get value directly like this, but it is a bad practice. We don't want to expose the important properties directly. Instead, we should use one of the two approaches to change the object's property. First up, by using the constructor method. It is a special method that is called when the object is created from the class. It initializes the object's properties and set their initial values. Here, when we initialize the object Thar, we need to pass the initial values so that the object can set its properties. Setting values using the constructor are generally used with those properties which we know won't change in the future, like the car will always have four wheels. One thing we need to understand here is this keyword. This is a whole new topic by itself, which we will cover in future. All we care about here, this in the constructor refers to the current instance of the car object. It distinguishes the properties of the current objects from the parameters passed to the constructor. Now, what if there was a property current speed which needs to be updated every second? In this case, we need to use the second approach, which is getter and setter methods. These follow the common naming conventions, which are get followed by the property name and set followed by the property name. The setter method takes the new value as the parameter and updates the property current speed with the new speed. The getter method is straightforward. It just returns the property like this. Now suppose we have another car Scorpio and both the cars are manufactured by Mahindra. And Mahindra decided to make some custom functionalities like maybe Mahindra cars displaying current weather. So they will create their class Mahindra, which will inherit all the properties and methods from the car class. This has to be done while creating the child class, or here the Mahindra class. We extend this class from the car class. The car class is called the parent class, and Mahindra is the child class. We can have the constructor class here too, where we can pass the default properties. Now, if you want to call or use the methods from the parent class, here in the child class, we have to use the super keyword. As you can see, we get access to all the methods like this. But what if we need to call the constructor method? For that, we just put a parenthesis after the super keyword without giving the dot. As we can see, the constructor takes 3 input and all Mahindra card has 4 fields, so we directly input 4 here. And besides that, we will pass speed limit and mileage like this. Here we need to keep in mind that this keyword gives access to all the properties and method from this class as well as from the parent class. On the other hand, the super keyword gives access to just the methods from the parent class. Here in this example, Mahindra inherited all the property and the methods of the class car. This phenomena is called inheritance. Think of it as you are the child like Mahindra and you inherit all the property from your parents. Now suppose the car class has a property of total distance, which should be private and accessible in just the car class itself and not in the inherited classes or the objects. What shall we do? In other languages like Java, we use the private keyword, but here in JavaScript, private is not supported. Instead, we use this hash symbol. Now we can see we get access to total distance covered property in this car class, but in the child class, we see JavaScript throws an error where it says That total distance covered property is not accessible outside the car class because it is a private identifier. We can always use getter or setter method for accessing those private properties. This phenomena where the property or the method is hidden or encapsulated from the objects or the inherited classes is called encapsulation. One of the main features with which encapsulation helps is data privacy. It shields the object's internal state, preventing direct manipulation from outside the object. This ensures the integrity of the data is maintained. Another feature is that encapsulation helps in the maintainability of the code. Changes to the internal structure of an object do not affect the external code. This flexibility makes it easier to maintain and evolve your codebase over time. By encapsulating, we can hide all the complex logics that are not required by us. Here, Mahindra need not know the logics that are performed while applying brakes. Objects of Mahindra just need to call the apply brakes method. This is called data abstraction. It provides a simple and a clean interface for interacting with objects and also reduces the complexity of the code.
What if?
There is another brand named Maruti. Now, to stay on top of the competition, Mahindra decided to add his own apply brakes method, which obviously prints Mahindra brakes applied. Now, let us update the classes of Scorpio and Thar to be that of Mahindra. And now, when Thar calls the apply brakes method, we get Mahindra brakes applied. So why did the apply brakes from the car class did not get called? Instead, apply brakes from Mahindra got called. This is because the compiler first searches if the method is provided by Mahindra. If it is present, it will run that. Otherwise, if that is not provided in this scope, the compiler will then look in the car scope. Now imagine the same method is also created by Maruti. But again, for obvious reasons, Maruti also prints Maruti brakes applied. At this point, the apply brakes method are present in three different forms, and this property where the methods can be present in different forms are called polymorphism. So that was it. Today we learned concepts like class and object, keywords we learned new, constructor method, extend, super, and we also touched a bit of this. After that, we learned the four pillars of OOP, which includes encapsulation, inheritance, data abstraction, and polymorphism. Hope you enjoyed the video. See you in the next one.
Don't forget to like and subscribe.